I'm Megan, and we are from the University of Miami's College of Engineering, Department of Biomedical Engineering, and this is a video tutorial for BME 440, which is biomedical measurements.
Hi, I'm Karen, and we're from the University of Miami.
Hi, my name is Garrett. Let me introduce to you our circuit of choice and the demonstration of the building of our circuit from a schematic to a breadboard. This modified Wien bridge oscillator has three output states, high, low, and oscillation, that depend on the input voltage here. It drives a bicolor LED to provide a visual indication of the input's relationship to upper and lower thresholds.
The circuit we'll be doing today has an operational amplifier. An operational amplifier does exactly what their name says. They amplify the input signal by hundreds of times. This is essential in biomedical instruments because electrical signals coming from the brain, for example, are emitted from 5 to 100 microvolts. This number needs to be amplified to a discernible level.
This circuit also has two capacitors. Capacitors are two-terminal electrical components used to store energy in an electrical field. They are quantified in units of farads.
The first thing that we're going to be using is the operational amplifier. The operational amplifier is a little chip that has 8 different pins, and this schematic shows what goes into which. Positive inputs, negative outputs, voltage out, and positive and negative power supplies. Whenever there's an arrow across a resistor, it means that it's a variable resistor. This is what a variable resistor looks like. And you vary the resistance using the screwdriver. And whenever you screw, it changes the resistance across these two little pins. The resistor across the two bigger pins is constant. The first thing we're going to do is hook up the negative power supply to ground. According to our pin configuration, we know that the 1, 2, 3, 4th pin is negative V and is hooked up to ground. We're going to make all these nodes to the side be ground. The next thing we're going to do is hook up the positive power supply. In our pin configuration, the positive power supply is on the 7th pin. 1, 2, 3, 4, 5, 6, 7. In series with the positive power supply, we have our capacitor, which is right there. And then, since it's kind of hard to get it all the way to ground, we're just going to hook up with a wire at the same node from the capacitor to our ground, which we said was all the nodes to the side.
Next, we're going to be adding a 10K resistor and this capacitor at the V out, which corresponds to pin number 6 in the op amp. To do this, you add the resistor at pin 6, and we're going to put it down here as well because we're not going to be able to fit it over there with the capacitor. So, to add the capacitor, it needs to be in the same node, so we're putting it next to it, and we're going to be pinning it down here. Now, to get it over to pin 3, which corresponds to right here on the op amp diagram, we're going to be using this yellow wire. And putting it into pin 3. Next, we're going to be adding this 20K resistor, which is in series with this capacitor. So to do this, we're going to be adding the resistor to where we added the capacitor before on the op amp. If I can put it in. And then we're going to be moving down here so we can have more room. Then this wire is going to correspond to VN, has to be in the same node, so in the same line, and this is grounded, so we're going to be putting this wire in order to jump and go to ground.
Here is the negative input voltage for the op amp. So what I'm going to do now is specify this node for V set and then connect it to another node with these two resistors exiting. So here is the negative VN on the op amp, and I'm going to make this V set. Now I'm going to connect the 10K resistor to ground from that node.
I'll be right back.
So now I'm adding the 5K resistor to that same node. And I'm adding it to the input voltage of 6 volts here. Now I'll be adding the variable resistor here, where the 10K is, from VSET down to the end of the op amp. So we're going here from this node that we've created, and inserting it here. Now we'll have to connect the end of that variable resistor to the op amp. So the red wire I just connected was going from the 10K resistor down to this op amp and the 10K resistor here. So now, from that node, I'm going to connect a yellow wire to a place where we have a little bit more space. So now I'm going to connect a 100 ohm resistor from the node that I just made to another place where the LEDs will be connected. So now I'll be connecting the red and green LEDs from that 100 ohm resistor, as so. And now the red LED. And now for the last two resistors. The 402 will be connected from the red LED to the 6 volt input.
We gotta leave that one.
And the last resistor, the 348, will be connected to ground from the green.
Now the schematic has been finished and it looks like this on our breadboard.
So we've hooked up the black cord to ground, VN, and also VCC, which is 6 volts here. Now, whenever I adjust the voltage input here, we can see that the red light lights up. And then when I add more voltage, the green light comes on. As you could see, our visual voltage tester was able to provide an indication of upper and lower threshold values.